All right, guys, lesson 2.4. We're talking about position, velocity, and acceleration. This is one of my favorite topics of the year. And it's one after today, it's going to keep coming up again and again because in Calculus AB, it's one of the main applications of derivatives that you're going to use and apply, where you can apply these derivatives to the real world around you. Some of this you may have done in a physics class already. You probably used a different type of math to do it. You may have used trigonometry to do some of these problems. Today we're going to teach you how to do position, velocity, and acceleration problems using derivatives. So, important terms that you need to know. Yes, I'm going to sit here and read this box to you. If you want to fast forward a couple minutes, you can. Position function. This gives the location of an object, okay? The position function is usually your original function, and it uses s of t, x of t, or y of t. Most of the time, we're going to use s, okay? Very rarely are we going to use something else. So the function s of t tells me where an object is. Okay, velocity function is the rate of change of the position. And we find that by taking the derivative of position, right? Because rate of change means derivative. So velocity is actually my position derivative. So velocity is actually s prime of t. Kind of cool. Now, something about velocity to keep in mind. If velocity is positive, that means you are either going up or to the right. Well, maybe not you. That means the object is moving up or to the right, okay? If the velocity is negative, the object is moving down or to the left. And I realize in the real world, there's more than left and right, but for the problems that we're doing, this should suffice, all right? Acceleration is the rate of change of velocity. Acceleration is the derivative of velocity. So it's the derivative, it's v prime. Acceleration is the derivative of velocity because it's the rate that your velocity is changing. Okay, usually we use a of t to represent acceleration. Okay, initial position. That's where we're starting at time 0. So usually that would be like s of 0. You would plug in 0, you'd find your initial position. Sometimes it's implied by s naught. That gives you your starting position. Your initial velocity is your velocity at time 0. Whatever speed, which seems weird, right? Because in your head, at 0, you're not moving at all, which isn't true because time 0 is just when we start recording what's happening. So starting velocity happens at time equals 0. Speed, this one is important because speed and velocity are really easy to mix up. Speed and velocity are the same thing, except that your speed cannot be negative. Okay, velocity, we said, if it's a negative velocity, you're moving to the left or down. If it's a positive velocity, you're moving to the right or up. Your speed, it doesn't matter which direction you're moving at a speed. You never tell someone, hey, how fast were you going? If you get pulled over and the cop says, do you know how fast you were going? If you say, I was going negative 55 miles per hour, that doesn't make any sense at all. You were going 55 miles per hour. It doesn't matter what direction you were going. So velocity, direction matters. Speed, direction doesn't matter. It's the absolute value of velocity, okay? Displacement is your change in position. So where you ended minus where you started, okay? If you started at 5 feet and you ended at 25 feet, your displacement is 20 feet, all right? Your total distance is different because your total distance is the amount of distance you traveled. So if we use our example 5 and 25, maybe you started at 5, but you went all the way to 40 and then you went back to 25. So your displacement was only 20, but you went from 5 to 40 and then back to 25. So you actually traveled what, 45, something like that. So total distance, you have to take into account when you change directions. All right. Okay. So example number 1, let's start actually doing some math. Hopefully you have stopped fast forwarding and reading through this on your own, and now you are actually listening to my beautiful voice. So example 1, if S of t equals t cubed plus t, find v of t and a of t. Okay, so it gives me my position function. It wants me to find velocity. Well, to find velocity, I just have to take the derivative of my initial function. So t cubed becomes 3t squared, and t becomes 1. My velocity function is 3t squared plus 1. Now to find my acceleration, I take the derivative of my velocity. Okay, my acceleration would be 6t, and that 1 goes to 0. Now, if we're doing units, it's not asking for units in most of these questions, but we're going to kind of talk about them a little bit. All right, obviously position, your units are, we're going to use feet. Velocity, that might be seconds or minutes depending on the problem. Acceleration is going to be seconds or minutes. That's going to be squared, right? So velocity is going to be like feet over seconds, and acceleration is going to be feet over seconds squared. Which might come up a little bit today. Maybe we'll use units even though it doesn't directly ask for them. All right, so example, moving on. Use the position function. S of t equals 16t cubed minus 36t squared plus 24 of an object. It's moving on a horizontal line. So we're going to use this same function for the next whole bunch of examples. Now, distance units are going to be measured in feet, and time is going to be measured in seconds. So again, on the AP test, if it does not specifically ask you for units, like number 2 says, what is the initial position of the object? It does not ask me for units, so I'm not going to use units on the AP test. I might use them today just a little bit, so at least you know what they are if they were to ask. So initial position, where we start, remember, is when my position function is at time 0. So I'm going to do 16 times 0 cubed minus 36 times 0 squared plus 24. This is 0, this is 0, this is 24. So my initial position is equal to 24, and my units would be feet. That's where I'm starting. I'm starting at 24 feet. That's my initial position. I don't know why, but it is. All right, number 3. What is the velocity of the object at time t equals 1 second? So it wants me to find velocity. In order to find velocity, I need my velocity function, which is the derivative of my position function, right? So to find velocity, I'm going to take the derivative. So 16t cubed becomes 48t squared minus 36t squared becomes 72t, and the 24 goes away. So my velocity function is this one right here. There's my velocity. So it wants me to evaluate my velocity at time 1. And it's nice it's giving us easy numbers to work with because this is not a calculator question. If it gives you really ugly numbers, it's going to be a calculator question. It doesn't give you ugly numbers on calculator questions. At least it doesn't normally do that. It wants you to focus on the calculus, not the algebra, so the numbers are usually a little bit easier to work with, okay? So V of 1, 48 times 1 squared, well, that's just 48 minus 72, because 72 times 1 is 1. So my answer here is negative 24 feet per second, right? My velocity is feet per second. So what does that mean, negative 24? That means I'm going my velocity is 24 feet per second to the left. That means I'm moving left, and I'm going 24 feet per second. That's what it means to have a velocity of negative 24 feet. I'm moving to the left. All right, number 4. What is the speed of the object at t equals 1? Oh, guys, I promise these two are going to get interchanged. They're going to both come up in the same problem. You got to be really careful. Speed is the absolute value of velocity. So if my velocity is negative 24 feet per second, the speed is just 24 feet per second. Simple enough, right? My speed is the absolute value of my velocity. It doesn't matter which direction I'm moving, I'm going 24 feet per second, or my object is. Whatever my object, does it tell us? No, it doesn't even tell us what the object is that's moving. Okay, number 5, what is the acceleration of the object at time equals 1 second? Okay, to find acceleration, I have to take the derivative of my velocity. So, my velocity function, it's highlighted up there in yellow. So the derivative is going to be, I drop the 2, that becomes 96t. The 72t becomes negative 72. So 96t minus 72. This one is my acceleration function. My velocity function's up there. Where was my position function? There we go. Let's keep track of these. Okay. So I have my acceleration function. Now let's plug in time of 1. So 96 times 1 minus 72. So my acceleration is going to be 24. And then be careful with your units. Again, it's not asking for units. But we're going to use them to practice so that at least if it does, you know what they are. My acceleration units are feet per second, which means feet per second squared. Because it's how much your velocity is changing. So 24 feet per second squared is my acceleration. What that means, what does that mean in the real world? That means I am accelerating to the right. Okay, I'm accelerating to the right, which gets into some cool questions later that you're going to have to answer. Sometimes it's going to ask you if you're speeding up or slowing down. So you have to consider which way am I moving and which way am I accelerating? Because if I'm moving to the right and I'm also accelerating to the right, I'm going faster. But if I'm moving to the right and I'm accelerating to the left, that means I'm slowing down. It's kind of cool problems. Okay, but it's not asking for that. Why am I talking about it? Number 6, when is the object at rest? Okay, it wants to know, when is my object not moving? And if you think about our 3 functions, we have a position function, we have a velocity function, and an acceleration. Those 3 functions, the one that talks about your movement is velocity. So if my object is not moving, that means my velocity is equal to 0. I should say v of t is equal to 0. So I'm going to take my function, 48t squared minus 72t, and I want to know, when is that function equal to 0? When is my object stopped? When is it not moving? All right, so let's factor out a 24 and a t, and I'm left with 2t minus 3 on the inside. So these two multiplied together equals 0, so 24t equals 0, and 2t minus 3 equals 0. Are you having flashbacks of math 2 and 3? So at time 0, my object is not moving. And I was just thinking, I thought earlier we found out that it was moving, but it wasn't. That was at 1 second. We were talking about it like it was at 0 seconds. So at time 0, my object is not moving. And also at time, that's going to be 3/2, my object is not moving. And maybe we should put seconds because we're trying to use units here, right? So at time 0, I'm not moving. And at time 3/2, I'm not moving because that would make my velocity function 0. We okay with that? So 0 and 3/2 or 1.5, whatever you want to use. All right, when is the object moving to the right? Gosh, I like this question a lot. Okay, my formulas, I'm gonna copy these down here really quick. My position, do we care about all of them? No. My object moving formula though, that's my 48, that's my velocity. And that was 48t squared minus 72t. Okay, so when is the object moving to the right? Now, if you think about velocity, when velocity is positive, my object is moving to the right. So when my velocity is greater than 0, I'm moving to the right. So here's how we deal with these problems with moving right and left or up and down. I like to make a little sign chart, okay? I like to make a little sign chart. Now here's what I know. I know at time 0, I am not moving. And I also know that at 3/2, I am not moving. At those moments, I am stopped. What I want to know is in between those moments, what direction am I moving? I'm stopping at 0 and at 3/2. But what's happening before I stop at each of those points? So I'm going to pick a number in between those points. And I'm going to pick the easiest number I can. I'm going to pick 1, and I'm going to pick -1, and I'm going to pick 2. Okay? So what I want to know is what's my velocity doing before 0? What's it doing at -1? So if I plug a -1 in right here, what do I get? I get 48 plus 72. I don't care what the number is. What I care about is 48 plus 72. That's positive. My velocity is positive at -1. I don't care about the number. I care about it being positive. So that means before time 0, I'm moving to the right. Well, let's plug in a 1 and see what's happening in between 0 and 3/2. So if I plug in a 1, I get 48 minus 72. That is going to be negative. Again, I don't care about the number. I care about the fact that that's a negative number. So at 0, I stop and I start moving to the left. Well, that's interesting. I'm going to the right. At 0, I stop, and then I start going to the left. Well, what happens at 3/2? Be really careful. Don't assume that you stop and change directions, because sometimes you've walked before. Sometimes you're walking in a direction or driving in a direction. You hit a stop sign, and you keep going in the same direction. Just because you stopped moving doesn't mean you changed what direction you're going. It just means you stopped because some kid rode in front of your car on his bike. That's what happens to me every single day in my neighborhood. Kids are dumb. It's like they want to get run over. So let's plug in 2 and let's see what's happening. All right. 48, that's going to turn into what? 48 times 4 minus 72 times 2. So that's what? 192 minus 144. Okay, so this is a positive number. So after 3/2, I do change direction. After that big speech about don't assume, yeah, hey, guess what? I changed direction. So I'm going to the right, I stop, I go to the left. I stop, I go to the right again. Can't make up my mind. Maybe I'm chasing a dollar bill blowing around in the wind. I don't know. So the object is moving right when t is less than 0. When my time is less than 0, I'm moving to the right. And when my time is greater than 3/2. So before 0 and after 3/2. Now, something to know on the AP test. You are going to get a question like this. There is nothing wrong with using this table. It's a great table. It does a lot of things for you. But you have to explain the table after. I can't just use the table and leave out the t is less than 0 and t is greater than 3/2. I have to take the information from the table and answer the question. At one point, people were just using the table and expecting to get the answer because the answer was in the table. Sorry, guys, that doesn't work. Make sure you say, oh, hey, t is less than 0 and t is greater than 3/2. Okay. All right, number 8, when is the object moving left? Well, the object is moving left. We already found that out when my velocity is negative, which happens right there between. So when my velocity, when time is in between 0 and 3/2. In between those two times, I'm going to the left. Notice I didn't put the equal signs under those my less than signs because at 0 and 3/2, we're stopped. We're not moving any direction. So it's in between 0 and 3/2, I'm moving to the left. Again, it's not asking for like units, but if you wanted to write seconds, you can. If it doesn't ask, I have a hard time doing it because what can happen is if you use the wrong units, you might get the question wrong, and that's no good. All right, number 9. When is the velocity of the object equal to 54? Okay, well, my velocity, I know, is 48t squared minus 72t, and it wants me to say when that is equal to 54. Okay, I will tell you right now, there is no way this question is getting asked without a calculator. That function right there, solving that right there without a calculator, you can do it. It's not going to be pretty. It's not going to be nice. It's going to take a lot of algebra and a lot of work that I don't care about you doing because I'm evaluating your calculus. So when you see this question, what you're going to do, on this one, I'm going to tell you to use the calculator, okay, because the numbers aren't pretty. And I wish in the textbook it said right there, use the calculator. But what I would do if I were you, I would go to my calculator and I would make this y1 and I would make this y2. So let's do that really quick. Go to my calculator. I'm going to go to y. I still have stuff in here from the last video. Let's delete all this. Why won't you delete? Go away. What is going on? Delete. There we go. That was weird. Okay, so y1 was, I forgot already, 48t squared minus 72t. So I'm going to do 48x squared. Yes, I know it's not an x, it's a t, but it doesn't matter. Minus 72x. I'm just using what my graph will graph, right? So 48x squared minus 72x. That's my y1. My y2, I want that to equal 54. So I'm going to put y2 as 54. And I like to do it this way because when I go to my graph, oh, I can't even see. We better go zoom. Let's do zoom fit, even though it might. There we go. Okay, so what I'm interested in is when this happens, right? I'm interested in when these two Why? Come on. There we go. I'm interested in when these cross each other. So I'm going to go second calculate, and I want the intersection. I want to know when these are the same. So I'm going to go over here I hit enter, and then I'm going to go over here to the right, and I'm going to hit enter. So my intersection, it says, is at x equals negative 5.49. X equals negative 5.49 is one of them. So let's write that down. X is time, right? When t equals negative 0.549. And then let's find my other intersection. So let's do second calculate intersection, and I'm going to move over because this intersects twice. It's hard to see on my picture because my calculator isn't as nice functioning as yours. My other time right there, x equals 2.049. So t equals 2.049. So when is the velocity 54 feet? Well, there's two different times, at negative 0.549 seconds and at 2.049 seconds. All right, that's where I have 54 feet velocity. Number 10, what is the displacement of the object between 0 and 2? Remember, displacement is how far I ended up from where I started. So I want my ending position minus my starting position. Now, I think we already found our starting position, right? Our starting position is 24, so this is going to be 24. I do need to find my ending position, S of 2. So I'm going to move up here and do it. S of 2 equals 16 times 2 cubed minus 36 times 2 squared plus 24. All right, so 16 times 2 cubed, that's going to be what? Because that's 16 times 8. This becomes 8. 16 times 8 is 128. 36 times 4 is 144. And then I have to add 24. But I also minus 20. Okay, so 128 plus minus 144 plus 24. So 128 minus 144 plus 24, that's my S2. And I'm going to minus my S0. So those are just going to cancel each other out. And I end up with 128 minus 144. So that's negative 16 feet. Because we're talking about distance, displacement. So negative 16 feet. And again, what does that mean? That means I end 16 feet to the left of where I started. That's what displacement means. I ended 16 feet to the left of where I started. Okay. Number 11 wants me to find the total distance traveled. So it wants to know, in that time frame, I know I ended 16 feet to the left, but what is the total distance that I traveled? Okay, so here's where I need to be careful. All right, so I know that I start at 0 and I end at 2. But in the middle, I change directions at 1.5. I change directions in the middle, okay? So I know my starting point was 24. If I moved 16 feet to the left, that means my ending point is 8, right? So I need to figure out 1.5, where am I in the middle? And again, to plug 3/2 into this function right here is not a nice thing to do without a calculator. So you're going to plug that in your calculator. You're going to plug 1.5 or 3/2 in, and you end up with, sorry, my calculator's being slower, -3. So you start at 24, you travel to -3, and then you travel to 8. So I want to know the distances here. going from 24 to -3, I end at -3. I started at 24, so I went 27 feet to the left. Then I ended at 8, but I started at -3, so I went 11 feet to the right. So if I went 27 feet to the left and then 11 feet to the right, that means I went, 38 feet total? Because even though it's a -27 feet, I traveled 27 feet. I don't care about the negative sign because I'm doing the absolute value of my travels. So I went 38 feet total, or my object did, whatever it is, my chipmunk or my pet squirrel, whatever. Okay, let's do a couple more. I know the video is running long, but this is one of those that, well, like any other one, I need you to understand things really well. And this one, I mean, that example was 9 problems, 9 different things that you're going to have to find on some of these homework problems. So number 12, 13, 14, 15. The graph models the position function. Okay, so I'm going to write position right here out of habit because I want to remember this is telling me the position of a radio-controlled model car. Answer these questions and explain. Was the car going faster at A or B? Okay, I know my position at A. I know my position at B. It tells me. But it wants to know when was I going faster. So remember, speed is your rate of change. That's your slope. So at A or B, which one of those is more steep? At B. So B, because the curve is steeper at B. My rate of change is faster at B. That's not where that answer goes. That answer goes up there. Oh, I love magic. Okay, 13. When was the car stopped? All right, let's think about what that means. The car is stopped when it's not moving, right? The car is stopped when my velocity is 0. My velocity is my slope. So where is my slope 0? It looks to me like from C to D. From C to D. My slope is 0, which means I'm not moving. At least it appears to be 0. We can assume. If it looks like it's 0, it's 0. Number 14, at which point was the car's velocity the greatest? All right, so when was my velocity the largest number? As I look at A, B, C, D, E, and F, B is the most steep in the positive direction, right? So B right here is really steep this direction. E, I think, is more steep than B, but my velocity would be negative. I'd be going down. And it wants to know when velocity is the greatest. So I would say point B, because that is where my curve is the steepest. All right. 15 wants to know when is my speed the greatest. Now here's where I would argue that the answer is E, because E is more steep than B. It's just going negative, but it is more steep. So the absolute value of my slope at E is greatest. I don't care that I'm going down. I'm going down faster than when I was going up at B. That's all that means, okay? All right, enough with the graph. Vertical motion. All right, something going up and down. Suppose S of t equals ugly numbers again. -16t squared plus 48t plus 160. This function gives the position above the ground for a ball thrown into the air from the top of a cliff. All right, so you've got, whoa, what just happened? You've got a cliff. You've got Josh standing on top. We don't have a Josh in this class. Who do we have in this class? Someone standing on top of the, I say that because I'm recording this video before school's even started yet. So I don't know who we have in this class. Person is standing on top of the cliff and they throw a ball and the ball goes up and the ball comes down. Swings his bat all the way around. If you know that song, I will give you extra credit if you can tell me the name of that song in class next time. You throw a ball, hopefully the ball hits the ground. All right. Find the initial velocity. Okay, initial velocity means v of 0. I don't have v. I only have s. So I've got to take the derivative of s first so I can get velocity. So negative 32t plus 48. That's the derivative of my position. The 160 goes away, t squared drops to t, and t goes to 1. So v of 0 is negative 32 times 0 plus 48. So my initial velocity is going to be 48. So that means at that moment that he who has not been named yet, or she, actually I think we have more girls in this class than boys. At that moment, the velocity is positive, which means they throw the ball up, not down or straight. They're throwing the ball up in the air, okay? At what time does the ball hit the ground? Okay, let's think about what's happening when the ball hits the ground. First of all, if it gives me my position function, s of t, my position is going to be 0. If I'm doing vertical motion, 0 is the ground. You could also argue that when it hits the ground, the velocity is also 0. I don't like that. That's a wrong argument, okay? When it hits the ground, it has speed. After it hits the ground, its velocity might be 0, unless it's penetrating the ground. But when the ball hits the ground, it is traveling at a speed. So please don't tell me that that is when the velocity is 0. It's when the position is 0. So I need s of 0. Nope, I don't need s of 0. I need s of t to equal 0. So 0 equals negative 16t squared plus 48t plus 160. Let's factor out that negative 16. So t squared minus 4t, nope, 3t, bad math, minus 3t plus 10. So I love doing that because when I divide that over, it goes away. So I end up with 0 equals t squared minus 3t plus 10. And we're going to factor that to be t, what? That's going to be t minus 5. No, it's a minus. Okay, I'm going, wait, that's not going to factor. I factored out a negative 16, so that's negative 10. There we go. That seems better. T minus 5 and t plus 2. I'm going to say this isn't going to factor, and I need it to. Which means that at time 5 and at time negative 2, the ball is on the ground. That's an assumption to make. The ball somehow started at the bottom of the cliff, though the person... So which of those answers makes sense in this problem? Obviously, the t being negative 2 doesn't make any sense. It's following the curve of the ball, which is why you get a negative answer. But we are interested in this one. At time equals 5, the ball hits the ground. Okay, so it took 5 seconds. I feel like that's a pretty good throw. Or you're just really, really high and it has a long way to fall. So at what time does the ball reach its maximum? Ooh, that's a good question. When does the ball reach this height right here? If this is my maximum height. So think about what's happening at the maximum. My s of t is the greatest number. It's the maximum, right? I don't really know how to find that. I don't know how to find the grade. I mean, we do using trig from other classes. But what I do know is the ball is going up and then it stops and goes down. And I think that's the key right there, is at the top, the ball stops moving. So my velocity is going to equal 0. At the top of my throw, when the ball reaches its maximum, it is no longer moving. It's going to start coming down. We're not going to talk about how to make sure it wasn't going down and then up. So I'm interested in, when does negative 32t plus 48 equal 0? When is that happening? So that means that 32t has to equal 48. That means t equals 48 over 32. So that means t equals 3/2 or 1.5. So at 1.5 seconds, at 3/2 seconds, the ball is at its maximum. So it takes 1.5 seconds to go up, and then it takes, 3.5 seconds to go all the way back down and hit the ground. So homework, let's talk about homework. All right, we are homework for 2.4. I know these problems are long. As I look through, and I'm actually looking at them right now, there's not as many questions because usually our homeworks have been like in the 40s, right? But if you look at like number 1 has A, B, C, D, E, F, G, and H. Number 2 has A, B, C, D. I know there's a lot of parts, but I need you to do all the problems. There aren't any that I want you to skip. I want you to get through as much of that as you can. Once you get to number 8, you're going to start, you kind of hit those review questions, and I know some of this stuff you're getting really good at, so those are hopefully you're getting better and better, and those are going faster. But do all the problems on the homework, and I'll see you in class.